Okay. And good morning, everyone. Welcome to SpaceGeekSpeak, our weekly AAA interactions on Saturday mornings. Thank you for waking up early. Grab your cup of coffee and prepare for great discussion with Dan. Thank you, Kumar. Yes, for discussion with Dan Adamo. Dan Adamo is no stranger to Johnson Space Center. He used to work at the JSC, and even yesterday I was sharing with Dan. I was talking with a couple friends and made the announcement at the event I was at, and that Dan Adamo will be at SpaceGeekSpeak, and a number of people have made comments that they know Dan and used to work with him and remember how great was working with him. So good morning, everyone, again. We're excited to have you join for today's SpaceGeekSpeak session. We have a fascinating presentation lined up that's sure to challenge some of your assumptions we all may have about the future of space exploration. Our speaker today is Dan Adamo, a highly respected figure in the field of space mission analysis. With decades of experience working on human spaceflight trajectory design and operations for NASA, Dan has a deep well of knowledge when it comes to planning for humanity's next great leap into the cosmos. Today, Dan will be tackling a bold and thought-provoking question in his presentation titled "Questioning the Surface of Mars as the 21st century ultimate pioneering destination in space." While many see Mars as the obvious next step for space exploration, Dan will be exploring whether the red planet is truly the best option or if there are others, perhaps more compelling destinations for humanity to consider. We are in for a presentation that promises to make us think and rethink what we know and open our minds to new possibilities. So without further ado, let's give a warm welcome to Dan Adamo. Dan.
Thanks for those kind words, Svetlana. It's a pleasure to be here with folks from Houston and not from Houston to talk about why is Mars so compelling to so many space programs. I'm going to start sharing, and I hate to take even more time troubleshooting, but I'm going to share my entire screen in the hope that that will let me show these charts that you are hopefully seeing here in a sort of a normal mode, show them in full screen mode. And can you see the full screen right now?
Yes.
Okay, so everything, we're showing the full chart at a resolution that hopefully fills your screen and field and all that. So I think this will work.
This is good.
Okay, great. And I will page down to the first chart, and hopefully that will show in its entirety as well. Is that looking good?
So far, so good.
Okay, well, we'll start right here. I hate to start with a word chart, but words are really important, and I want to get some terminology straight because the key in the title of this presentation is pioneering. And pioneering sometimes gets interchanged with all kinds of other terminology, to which I want to draw a very important distinction. Let's kind of dissect some of the terminology here. So foreseeable human-initiated activity in space can be divided into two categories. Exploring, and we've been doing exploring since even before this example I give here, but take Lewis and Clark circa 1805 with their core of discovery. That's surveying foreign territory. At least the white European demographic had never been to this interior part of North America before. And that kind of surveying foreign territory is a major component of NASA's charter. Explore and its derivatives appear throughout the Space Act that formed NASA in the late 1950s. And it can be conducted by humans directly, or as JPL is fond of showing us and other agencies, by autonomous robots under human control. There's a distinction you can draw when you're using robotic surrogates, is that if they're stationed less than 100,000 kilometers away, and I'm just using a rough order of magnitude, but if they are close enough, you can do a virtual human presence if you have like a dedicated communication system that allows you to pretty much limit the lag in response to a command by just the speed of light. So you got a round trip of 200,000 kilometers or less. Well, you're going to be able to do just about any task you can imagine, particularly with today's state-of-the-art robotic interfaces. So if we can get humans close to these robotic explorers, we can do an awful lot of stuff. In fact, I like to challenge planetary scientists and other exploration investigators. What can't you do under those circumstances that you've got something that close with a state-of-the-art robotic interface? Yeah, what is it that you need to do that you can't do it? Pretty much nothing that I've heard from any scientists. So, problem with Mars, of course, is it never gets closer than 56 million kilometers to Earth. So you're pretty much stuck with robotic surrogates being in a high latency mode. And of course, this is the best case, 56 million kilometers. It could be across the solar system from the Earth. And you wind up with the better part of an hour of data latency. So you say, do this, and a half hour later or 45 minutes later, you see the robotic response. So that's what I mean by exploring in this in this presentation. Pioneering is something totally different. If folks want additional reading on pioneering, particularly at Mars, but anywhere in space, I just read an excellent book this summer called A City on Mars. And it's really some fascinating research into some areas that I don't explore in this pitch. There wouldn't be enough time. But pioneering is akin to what the Pilgrims did circa 1620. You put down multi-generation roots in foreign territory. That is not in NASA's charter. And it must be conducted by humans in situ, or and ultimately those humans have to return some kind of sustained profit, or nobody's going to support them in this pioneering role that they've assumed. And if that's the case in any off-Earth pioneering destination, it's almost certainly fatal for the pioneers. Certainly, we see examples in our own history, just pioneering remote environments in the Earth, Antarctica, Jamestown, the list goes on and on. So you really have to have your act together, and you can't use robotic surrogates. So, for example, anything we have to date in space is dubious and Earth-centered, like communication satellites. Well, we're turning a profit operating communication satellites, but there aren't any humans in situ on the satellite making it possible. Thank goodness, because they would probably perish for lack of support, and a variety of other issues that we'll go into in subsequent charts. So Mars, as the title implies, is widely accepted as the ultimate 21st century pioneering destination in space. It's our horizon goal, as NASA likes to say in their roadmaps for human exploration. I mean, they are not in the pioneering business, but nonetheless, it's a horizon goal. So you have to wonder what's justifying that. A lot of people are using pioneering as justification, that we need to be, as Elon Musk says, a multi-planet species. And just in making that statement, Elon and folks like him have already biased what the possibilities are out there. And I submit that developing any bias like that, saying, okay, we're going to inhabit multiple planets, ignores some real revelations and very pertinent information that we've been getting since we started the space age. Nevertheless, you got to ask why 202,000 plus adults would volunteer in 2013 for a one-way trip to the surface of Mars. That's the number of applications actually completed and submitted to this Mars One project that you probably heard about in the news. I'm sorry, and that that's not the number of applications actually completed. It dwindled down to 4,200, and that number got narrowed down a little more by a selection process, but because of lack of funding, the real money, the way Mars One saw it, was in actually sending people to Mars and doing like a reality TV show and getting revenue from advertising on that. Well, that turned out to be quite a stretch, because even the most optimistic forecasts that they gave for putting people on Mars were no earlier than this year, 2024. And there was just too much time and too much money required for sponsors to come out of nowhere and fund what turned out to be a very risky and very costly enterprise. So I'm asking, might there be more accessible and hospitable pioneering destinations than Mars? And that's what the rest of this pitch is about, as well as trying to explain a little more about why we have this Mars destination fixation. Any questions so far? I'd like to entertain questions as we go.
Well, I have a question. You say that pioneering is not a NASA charter, not in NASA's charter, and must be conducted by humans. What about the NASA program, the Pioneer series of spacecraft that NASA launched in the early 70s? Pioneer 10 and 11 went to Jupiter and Saturn, first spacecraft to Jupiter and Saturn. And there were earlier pioneers than that explored the environment of the sun. So are you saying that those that entire mission series was misnamed?
According to the nomenclature I want to impose. Now, you know, NASA's famous for fanciful project naming. You know, for example, Mariner was a program that ran concurrently with Pioneer. And it's not like we were sending sea ships out into space. You know, you can't literally take the program name, and I don't really have a problem with program names being a little fanciful, but that's all it is. And no, it's not consistent with my definitions. And that's why, you know, your question is quite appropriate. That's why it's so important to get this terminology straight. Hopefully everyone knows what I mean by pioneering. You know, that's a human only kind of activity. You can't trust proxies to do that. So that's why I say, and if you look at NASA's charter, there's nothing about pioneering in space, particularly with humans, but I don't think when I scan through the National Space Act, their pioneer did not occur anywhere in the document. So I hope you're satisfied with that answer, because I can't deny that NASA uses the term pioneer in its derivatives. But
I was under the impression all this time that pioneering is exploring the unknowns. That's what it was supposed to be, taking steps for exploring the unknowns, but still exploring. That's what the understanding I had all these times.
well, that would be consistent with what I'm saying. So hopefully everyone can live with those definitions. And then if we need to take any exceptions to them, I'm certainly open to hearing about it. Okay.
So I'm confused. What is the difference between exploring and pioneering?
Well, it's there in those bullets. I hope I've made that clear. Exploring can be done by humans or robotic surrogates. You are trying to survey foreign territory, and you may do that through your own eyeballs and your own fingers, or you may do it through a robotic surrogate with some degree of data latency. And in the case of Mars, that data latency is kind of hobbling. If we could get into a mode where we were exploring Mars from less than 100,000 kilometers away with humans operating robotic surrogates, the loop between a command being issued and the result being seen back by the command issuers, that loop would be a fraction of a second, ideally, so that if you had a state-of-the-art robotic interface with the humans nearby, they could tie a shoelace if they needed that degree of dexterity, because they would get immediate feedback for every robotic command they issued. And you could do things like surgery on Mars from orbit around Mars, for example. But if you're confining humans to Earth the way we do today, you're talking about actually days to turn around the command loop. You take pictures as to where you are. The robot does on Mars, sends them to Earth. There's overhead in doing that because they have to go through an orbiting relay satellite, and then you've got processing to do on Earth, and then generating commands that then get sent directly back to the robotic surrogate. And
yeah, Dan, I understand all that. So I think what you're saying is pioneering has got to have humans in the loop, and humans are doing that while exploring is done by remote sensing and other instruments that go into places where humans are not there.
Yeah, Mike and Dan, let me just take one shot at that. Mike, your question is the difference between pioneering and exploring. And the way that I see, or many, that it's in the purpose. The goal for exploring is to learn, observe, and collect data potentially about a place that has not yet been fully understood or assessed. But it is really that the difference is those are two different distinct approaches in the context of any travel and space travel as well. And it's a discovery and expansion, one of the steps of the discovery and expansion of new frontiers. So the exploring, you do it temporarily. And pioneering is the purpose is to create sustainable infrastructure and develop the human presence. But essentially, pioneering is that you want to establish long-term settlement, and exploring is the traveling, investigating, but a temporary in nature.
Yes, and let me just slightly correct what Mike's saying. Don't fall into the trap of thinking exploring has to be done by robots. It can be done directly by humans, as in the Apollo moon landings. They landed on the moon, they spent at most 3 days there, and then they took off back for Earth. And that is not pioneering, it's exploring.
But your definition says that pioneering must be conducted by humans.
Yep.
And so the difference is humans are involved in pioneering directly, whereas in exploring, it doesn't have to have, it can have humans, like Svetlana says, but it is done maybe before pioneering and done with remote sensing and space probes.
Yep, that would be a rational program. You want to.
Okay, well, I can go along with your
before you-
definition, but that is very much different than NASA's concept, as I
Actually,
understand it.
Mike, if you want to write me some email and ask me for a NASA reference that is consistent with these definitions, and I'll send it to you.
Okay,
Okay.
okay.
All right, let's proceed. I don't want to spend too much time on definitions. And, like I say, if you want to come back to those in the context of subsequent charts, we will certainly do that. So history, I love history. That quote from Harry Truman is only too appropriate in my experience. The only thing new in the world is the history you don't know. And, history indicates humans pioneer for compelling reasons. They want to escape from war, starvation, persecution, and pestilence. The don't fence me in mentality, land grabs like the Oklahoma land rush, motivated by overcrowding, limited opportunities, and poverty. Reasons to pioneer in space are relatively abstract, however. There's no predictable threat to widespread survival on Earth for at least the next 100 years, and I'm drawing that number from our planetary defense initiatives that take every known asteroid, and they're numbering in the tens of thousands, at least the ones that have orbits close enough to intersect Earth's. And we take them out for 100 years, and we don't see anything that is a credible probability of impact for an object large enough to threaten the entire species. So, and on the other side, there's no unobtainium we found in space yet that compels us to head out there and go prospecting. In fact, I would submit that if we did find something like unobtainium out there, your profit margin would be a lot heftier if you used robotic surrogates. Your margins are so much greater because the masses you have to transport out there to do the mining and refining are so much less. That just hasn't been much of a motivation so far. And even if it is in the future, we find solid platinum on an asteroid out in the main belt, it'd be so difficult to get humans out there that you would probably find robots doing the job. It might take a while to get them reliable enough, but much better than people on a suicide mission. There's no known hostile natives on the way to Mars, but as most of us are familiar, transport to and from Earth involves huge distances, delayed responses, and immense energies. Threats from exposure to temperature extremes, vacuum, radiation, and reduced gravity are ever present. Habitats tend to be cramped, stuffy, and insulated from outside scenery. And diets with fresh produce may be problematic over protracted intervals. I mean, even with the relatively short supply line to International Space Station, the first thing that gets unpacked when a visiting cargo vehicle docks the station is the fresh produce, the citrus fruits and vegetables and all that kind of stuff. And they go fast because they really can't be preserved very well aboard station. So with all this negative influence or prospects for space pioneering, Mars is evidently a socio-cultural destination. That's what a sociologist colleague of mine termed it. And we'll go through some examples of that. Intelligent life has built canals there. That we've been assaulted with this kind of propaganda, I'll call it, for over a century. This is what Percival Lowell was saying based on some misinterpreted research by the astronomer Giovanni Schiaparelli a few decades before, where he thought he observed these lines on the planet, which you can see sort of illustrated here in this cover, and he called them canali because in Italian they described what he saw as channels, which is all too possible. But when it got over to Percival Lowell and others who spoke English, canali meant canals. And that's a gross misinterpretation of what really was some bona fide scientific research, and it sort of turned into more science fiction. Sure enough, it didn't take long for the science fiction writers to get into it. Edgar Rice Burroughs, circa 1912, was publishing these fantastic accounts, stories, yarns, some of which, I mean, they're very entertaining. I even enjoyed the Disney remake, what was it? Jonathan Carter on Mars, I think it was called. It was, very entertaining, but not an accurate description of life on Mars, which we still may encounter, but I doubt it will be creatures like you see illustrated here. And that's just the beginning. I mean, very famously, the novel by H.G. Wells, War of the Worlds, was dramatized in 1938 by Orson Welles and broadcast over the radio and sort of parochialized into a Martian invasion of New Jersey. People were actually committing suicide because they didn't realize this was a dramatic portrayal and not a news account. And you can see Wells here broadcasting over the CBS network very dramatic fashion, and actually succeeded in convincing people it was happening in reality, which led to all kinds of legislation about identifying who you are and what you're broadcasting periodically, every hour on the hour, whatever. Getting more into some of our lifetimes here, Ray Bradbury, circa 1950, The Martian Chronicles. It's human destiny. We're going to wind up colonizing Mars, and it's very habitable. Look at the nice blue sky. Higher order beings there inhabiting the planet. And then getting into the space age, actually a little before the space age, people like Wernher von Braun were actually running the numbers. The interesting thing that Werner's research that led to this Das Mars project, or the Mars project when it was published in English, he ran his numbers probably getting bored waiting out in white sands to do some interesting rocket science. And so he ran the numbers and fleshed out the computations for flying to Mars, and even down to the vehicle masses. And you can see, we knew so little about Mars that he was going to spend a lot of mass transport propellant using these winged vehicles to fly humans to Mars. And it turns out, there's no atmosphere that could give you any kind of lift on a wing like this to justify the mass. So it just, shows, okay, this is kind of a flight of fantasy, even with the father of the U.S. space program, or one of the fathers of the U.S. space program, doing the computations. But the interesting thing about what von Braun published is that he ran the comps in circa 1947 for a mission that would be held 20 years later in 1967. And so there was like this 20-year lag, and that lag has just slipped year for year to the point now where, we wanted to put humans on Mars in the 2030s with a NASA program. I don't think that's going to happen. It's going to happen in the 2040s at the earliest, and that assumes a lot of funding that we don't have right now. This Wernher von Braun effect plagues us to this very day. And then, NASA's gotten to Mars with these robotic surrogates, like we mentioned earlier. And this is a view shot by the Curiosity rover around 2012. And it's just amazing. I mean, you'd think you were in the American Southwest looking at some kind of butte here or something in a very desert environment. And, my imagination is kindled with that kind of view, and I'm sure others are too. That's leads us to the Mars One program that I mentioned earlier. This is a URL that when I checked it this past week, I don't have the password to access it anymore. It's not a public website anymore. So this access date is the last time I could get there with any kind of functionality. And you can see that, they were thinking that they'd be sending these robotic precursors that we mentioned earlier, around 2018, and that we'd be sending humans by this year, 2024. But then they had to revise that because their funding didn't materialize, and then they were 2031, and then they didn't know when. So,
question.
Yes, go ahead.
Who owns this URL, and is this NASA's URL? I don't see anything here. Or is it from a company?
It was a company. I don't know if they're actually viable anymore. And like I say, the URL, if you go and go over there to that website, you can get there. It's a valid URL, but they say you don't have the password. At least, I don't have the password to actually gain access to the data content. So you won't be able to see this image anymore. This image is so badly outdated because these landing craft here probably look vaguely familiar. They look a lot like a SpaceX Dragon. And indeed, they were a Red Dragon SpaceX vehicle design that would be capable of landing on Mars. Yes.
That's why I asked the question. This doesn't look like what I have seen coming out of NASA for the last 40 years. But anyway, go ahead.
Yeah.
Some kind of business.
A private, Kumar, it was a private entity, but in 2019, I believe it declared bankruptcy. So it's not viable at the moment.
Yeah.
Okay, I got it. Thank you.
But they fooled a lot of people into wanting to take one-way trips to Mars. And here's the kind of the fallacy in that. Zooming in on a couple of these landing craft, they have the connecting tunnels out back where there's a greenhouse and all that kind of stuff. You see a suited pioneer, we'll call him, here, and he's got this unpressurized rover. He can hop aboard and tool around the local area. That's kind of a risky proposition. First of all, radiation exposure. Above surface habitat spacesuits and unpressurized rovers provide inadequate shielding to support 500-day duty tours. And that's sort of like what you sign up for if you want to come home, is a minimum of 500 days, let alone the multi-generation pioneering. And that book, A City on Mars, tries to draw that distinction. It's one thing to sign up for a mission with a planned out finite duration. It's another thing to say, I want to spend the rest of my life here raising kids that'll, carry on the family tradition. It's insane. And movies like The Martian, and the book is just as bad. The Martian give all kinds of incorrect perceptions about how daily EVAs, going out in your spacesuit, with an atmosphere that's 1/1000th the density of the Earth, so it has no protection from any incident radiation, solar or galactic cosmic radiation. Going out there every day to work for a few hours like you would in a normal career, is fatal. Mark Watney would have come back with probably an advanced case of leukemia or other cancer from all his exploits on the surface. A great, once again, like Robinson Crusoe on Mars, or I'm sorry, John Carter on Mars. A great yarn, but far from reality as we see it, as science would see it today. Then there's a problem of reduced gravity. There's no evidence supporting multi-generation human adaptation to 1/3 gravity on Mars, after we've evolved millions, maybe billions of years of genetic heritage here on Earth at 1G. That's the one thing that's pretty constant about evolution of life on Earth. It's been 1 gravity the whole time. So that you don't have that evolutionary influence trying to push life to evolve to different levels of gravity. It just has no experience there over the many, many generations required to adapt. So as a consequence, we may have to rotate our habitats to produce more Earth-like artificial gravity. And that's harder to do on Mars than in space, because you have this downward bias to the gravity field that you are trying to amplify, but you're trying to do that by rotating your habitat. So it's going to have to be like a tilt-a-whirl kind of proposition, where it takes advantage of that gravity only in certain parts of the rotation. And as the folks the folks that authored A City on Mars observed, if you make your centrifuge, your rotating habitat centrifuge, with too short a radius, you'll be constantly assaulted by nausea. So it has to be quite an involved affair, tens, maybe hundreds of meters in radius to get rid of Coriolis accelerations that drive your inner ear nuts and pretty much give you nausea full time. And then finally, most recent finding from analysis by these robotic rovers is that there are perchlorates and hexavalent chromium prevalent throughout Mars soil and dust, probably because of these global dust storms that occur every decade or so. They just spread any kind of toxic chemical globally. So we got some real work cut out for us. If you want to do farming, for example, agriculture on Mars is not going to be easy. And I have some experience with this because I've participated for the last 2 years, and again, I'll be doing it this fall semester, in a project called Martian Greenhouse. AIAA's kind of involved in sponsoring that with folks that will mentor high school students trying to come up with proposals for Martian greenhouses. And it is a tough job. So any questions on that? Okay, here's really a more realistic, and I point the Martian greenhouse students to this illustration, which was, I've got a URL if you want to see this and many other illustrations of Martian habitats. But this actually comes from a rather accurate docu-series, I'll call it. It had drama interspersed with documentary type footage that National Geographic produced, geez, I think it was like 2019, somewhere before the pandemic. And it was just titled Mars. So if you Google Nat Geo Mars, you'll probably be able to see most, if not all, the episodes of that series. But you can see here's like a surface cutaway with some type of portal where maybe you could lower people down in here to a lava tube or some type of underground cavern It's not pressurized, so you still need these pressurized domes. And you can see people inside them in shirt sleeve environments. And then when you go outside, you need a spacesuit just like you would on the surface of Mars. But there's very little radiation that can penetrate through meters of rock. So at least you've addressed that problem, and might have a chance of keeping people here for a lifetime if all the other problems we've talked about, reduced gravity, and making and some type of agricultural proposition work out. I mean, this is a common area here, a lab here, and this is a greenhouse. So with this kind of energy, you're going to need this kind of energy demand. You're probably going to need something like nuclear fission to power it all. Plus, you're going to need some glacial activity, some type of water deposit nearby, so that you can hydrate, have hygiene for the humans, and something to flush a John with, no doubt. That's going to hopelessly contaminate any Martian biosphere that still exists. And to me, that's a real shame, because any scientific rationale for exploring Mars, whether you want to do it short-term or long-term, exploring Mars has as its foremost rationale the search for life on Mars, and particularly extant life on Mars depends on us not flushing the John in proximity to glaciers and aquifers and all that kind of thing. So bear that in mind, Elon, when you go to put 1 million people on Mars in these nice domed palaces on the surface where everyone's going to get fried. It's got to look a lot different than what illustrations I've seen come from SpaceX. And at this URL, I don't recognize any SpaceX-like illustrations. There's some really good stuff there. And I owe, apparently I owe Svetlana the charts. You can either write me directly or write her after I send them to her, and get a copy of these charts, and all the URLs and the charts are clickable, so you can go to the sources on citing. Any questions there?
That's great, Dan. I appreciate having the access to these charts. Thank you.
No problem. Yeah, happy to share. These are not proprietary by any means. So here's an interesting thought experiment I played once. What off-Earth location offers these hospitable ambient living conditions that human pioneers on the surface of Mars would envy? Atmospheric pressure near 66% of Earth's at sea level. So, that's radiation equivalent to living at 3,500 meters on Earth. And I mean, there are cultures living in the high Andes and Himalayas that have that 66%. Temperature near human body temperature, gravity near 89% of Earth's at sea level. Well, I won't play the game with you any longer. You can get all those conditions in a floating habitat 52 kilometers above the surface of Venus. Unfortunately, the location lies near the middle of a sulfuric acid cloud deck extending from 30 to 75 kilometers above the surface of Venus. But the view from a subsurface Martian habitat would be no better, as you saw on the previous slide. If multi-generation survivability off Earth is our primary consideration for pioneering, then the atmosphere of Venus is arguably a better pioneering destination than the surface of Mars, from what little we know about human adaptation to off-Earth environments. And you can get more information on this concept from Langley's high-altitude Venus operations concept, HAVOC, at this URL. Any questions on that? It's sobering, but we don't have anywhere near the amount of sci-fi literature bombarding us about pioneering on Venus for the past century. So that's my best explanation as to why people aren't into Venus. Because we were ignorant about those ridiculously high, 800 C surface temperature on Venus until well into the space age. So,
I've got one general question, Dan. Anywhere in space, if they don't have the proper gravity, we need rotations of those items to create artificial gravity. Is it really valid everywhere? We talked about Mars, but is it also valid on Moon or any other place? Floating, of course, you need to provide those rotating on that one, but
yep.
something which is actually sitting on the surface, you still need rotation to really for artificial gravity?
I don't know. And that's really the bottom line. I don't know. And what really disturbs me is in any of the technological roadmaps NASA's developing to just explore out there, not pioneer, just explore out there temporarily, they have no plan for finding out. And so when we send people to the moon, and let's hope if they're spending more than a week or two there that we do the responsible thing and put them in a lava tube or something subsurface. We don't know what 1/6 gravity will do to them over long time periods. Now with the moon, you could maybe responsibly hope to bring people back if things went wrong in a pretty prompt fashion, right? I mean, it's a 3-day flight back to Earth. Due to the architecture of that transport, you might have to wait another week or so for proper alignments to occur between orbit planes and the Earth. But be that as it may, certainly under a month, you could have anybody starting to deteriorate under 1/6 gravity back at the home planet for rehab. And from our experience at 0G, we know that's probably not going to be some kind of runaway effect, because 0G is probably worse on adaptation. But once again, we aren't sure. And then 1/3 G, well, that's a little nasty, because if you want to send somebody to Mars and they can't adapt to 500 days, they're years from coming home. And so to be responsible about this data gathering with humans as the guinea pigs, because yeah, you can literally use rats and guinea pigs if you want, but you won't be sure about human adaptation until humans are subjected to these conditions. I think the only responsible way, and you can do it for the moon too for that matter, is to get into low Earth orbit with something in an orbit like the space station that has a habitat and a tethered counterweight so that you can spin the whole affair up around its common center of gravity, and you select what length of tether you use. You select the rotation rate so that you generate the desired level of centrifugal acceleration to simulate gravity, and see what, first of all, you can avoid nausea with a sufficiently long tether. What's that prescription? And then finally, what's the gravity prescription? Can you despin this affair periodically and then just respin it to recondition the inhabitants? All those protocols could be developed in low Earth orbit instead of sending people out to Mars and hoping and praying that they're able to survive several years away from.
So probably if the individual on the surface can live with that 89% after what we call the climatizing training and adaptability, we might not need those rotation.
That's right. Yeah, you might
thinking.
get away with this 89%, but unlike altitude on Earth, there is no variable gravity. Altitude affects atmospheric pressure, but it doesn't substantially affect the pull of gravity. So yeah, we're all we have are really 2 data points, 1G and 0G, and then there's this 1.6G where we've had 3 days of experience, which isn't enough. So yeah, that's where we're at right now, and we've got a lot to learn.
So Dan, my concept is that yeah, there's some things you can do about spinning spacecraft to take care of temporarily to take care of small gravity effects. But my concept is that on Mars, over generations, the humans there, if they would survive, they would evolve into a humanoid that would be able to accommodate lower gravity. Matter of fact, if you put that humanoid back on Earth, they would suffer very, very deep problems. And so over time, the evolution, and I don't know how much time, maybe even just 1 generation, but at least several generations, you would have a humanoid on Mars that would accommodate the lower gravity, and then they would become Martians, true Martians.
Yeah,
So,
yeah. This reminds me of the Prime series Expanse, The Expanse. Have you watched any of that?
I am not familiar with that.
Oh, the Expanse, particularly if you already have Prime. It's about that kind of a future where there are Martians, like you described. There are belters who mine resources out in the main belt, the main asteroid belt and farther, who deal with microgravity all the time. Like Ceres is the biggest gravity field they've ever seen. And even getting Martians back to the Earth requires all kinds of physical regimen and drugs to prepare for the journey, for arriving on Earth in 1G.
Yeah, I agree with that. The idea is over generations, the human substance will evolve into a living organism that can withstand the environment that it's in.
And if you really want to go extreme, there's always genetic engineering.
Oh yes, right.
And it's hard to say you can even call those humans when you achieve a solution. And all this stuff is possible. What I really want to caution folks about is doing it responsibly, ethically. That's what I fear most, is that people would just go off half-cocked, like, who's going to stop Elon from sending people to Mars and seeing if what you are speculating about can't be made to pass.
Well, those are good words. However, going off half-cocked sometimes it separates the survivable human people from the unsurvivable, and so that's what evolution is all about. And so half-cocked is the strategy that's used by nature.
Yeah, but not on Earth so far with this experiment. So we'll have to see what happens.
Okay.
Anything is possible, and you have to be careful what you wish for. In this case, I think it's the words of caution I would urge on people. So what I want to turn to now is small bodies in the solar system. Many of them are easier to access than the surface of Mars. And this is a chart adapted from one that you can find at this URL by my colleague Brent Barbee, who has done a lot of really good work that's inspired some more work by me on determining the accessibility of near-Earth asteroids. Asteroids that aren't in the main belt between Mars and Jupiter, but rather tend to be in Earth-similar orbits, at least the most accessible ones. And this chart in 2 dimensions tries to come up with a metric for accessibility for human spaceflight. So this horizontal axis here shows the round trip flight time in days. And then the vertical axis on the chart shows the minimal round trip delta V. So it's change in velocity, starting in low Earth orbit, going out to the destination, stopping, landing, whatever, then taking off or departing and coming back to a direct entry at the Earth. So it's a simple round trip with virtually no delta V required to come back to Earth. Although most of these data points on this chart insist that you come back at less than or equal to 12 kilometers per second when you hit the atmosphere. And if you don't, if you would naturally come back so fast in order to meet a round trip transit time that's shorter, if you come back so fast that you would bust the speed limit, then there's a maneuver required for additional propellant expenditure such that you do adhere to the speed limit. If you satisfy all the many criteria of this software package called NATS, stands for Accessible Near Earth Asteroid Human Spaceflight Accessible Target Study, NATS. You can Google NATS as well and see the results of daily updates that JPL performs to the NATS database of accessible small bodies. But this actually goes beyond NATS to look at where have we been and where do we want to go. And you can look at, here's the moon in various shades of green. This is where we went with the Artemis 1 mission, 70,000 kilometer lunar distant retrograde orbit with Earth return less than 11 kilometers per second because you're so nearly orbiting around the Earth. And that's this little point. Actually, you could stretch it out to the right because you can come home anytime from the moon. So all these moon green regions are infinitely to the right if you want them to be, but this would be like a minimum duration. And then here's landing on the moon. I'm sorry, it's not landing on the moon. It's going to low lunar orbit, and that'd be like Apollo 8. And you can see that just lowering the orbit from 70,000 kilometers to about 100 kilometers, that gives you an additional half kilometer per second that you have to take on. And then if you actually want to land on the moon, well, that almost doubles the delta V you have to expend, which is why it's really smart to do lunar orbit rendezvous and stage the flight plan so that you get rid of some mass and go to minimal mass. You also get rid of a crewman in the Apollo case, and then go with minimum mass that actually gets deposited on the moon's surface and then has to take off again. And of course, there's another staging event that occurs at liftoff from the moon, again, to keep the mass minimal that has to be accelerated. And then here are all these various Mars mission modes, elliptical Mars orbit with various loiter, just 7-day loiter, 45-day loiter in Mars orbit. Venus gravity assist helps lower the delta V. It might also increase the transit time out here in some of these points. And here's your Mars surface with a 500-day loiter. And then a Mars 500-day loiter in an elliptical Mars orbit that might help you in some geometries. It might help you reduce the delta V down toward 6 kilometers per second. But you're just in Mars orbit here. You're not actually going to land. Once again, look at sort of the mean value here of 8 kilometers per second delta V, and then the landing almost doubles it. You're pushing 14, 15, 16. When you go deep into a gravity well, even one as shallow as the moon's, you almost sign up for almost double the delta V. And so if you go instead to a near-Earth asteroid, and there's over 5,600 of them that satisfy these sharp cutoffs here. That's what the NAT software uses. It says, I'm not looking for anything where you can't go out and come back with at least, I think it's a 5 or 6 day, it says it right here. Loiter has to be greater than or equal to 8 days. So you have to come back with the Earth return speed less than 12 kilometers per second. And you have to come back within 450 days of departing the Earth. And then your round trip delta V is also less than 12 kilometers per second. So that's
Dan?
why the top line is straight and the right line is straight, because it got time of flight and delta V limits. And then you can see some of these really cheap missions, if you want to spend about a year in space, which, you know, we've done on the space station. So we're not talking about conditions much different from space station. The big difference in my mind is that going out to a near-Earth asteroid in its native orbit, you're going to go in interplanetary space where you have types of radiation, such as galactic cosmic radiation, that are different from what space station crews experience. These high speed, you know, near speed of light, highly energetic nuclei with atomic masses like, you know, near iron. So that stuff can generate an awful lot of ionizing radiation and really mess up your DNA if you get exposed to a lot of it. So that's different than space station, because space station operates inside Earth's magnetic field, which deflects a lot of that cosmic radiation and solar radiation for that matter. But still, down here in one of these missions, you're talking about space station-like durations. And the delta V is less than what Artemis 1 had to expend. So it's like, wow. Of course, there's 5,600 of these puppies in this region here, 5,600 asteroids, which have some of them millions of mission opportunities reckoned at 5-day granularity in terms of departure time, arrival time, all that kind of thing. Or is it 8 days? I guess it's 8 days. I'm sorry. I'm used to using another processor that's similar. So this whole proposition of going off to Mars and the moon may actually be eclipsed by some of these small bodies, and they may be, you know, you can construct a subsurface habitat that's radiation shielded, spin up the habitat. There's no gravity, so you don't have to worry about gravitational field biases. You know, all that kind of stuff is there free of charge, except for emplacing the habitat. So it's not much more than constructing a space station. I think once we get used to operating in and around small bodies, and we're getting more experience all the time with these robotic precursors, just like we talked about earlier. Any questions on this chart?
Yes, Dan, this is Kumar. What I am wondering is, I don't see anything that Moon and Mars offers us in taking humans to asteroids and you know, near Earth asteroids. Here's what I mean by saying that. The temperature environment, the radiation environment, gravity, etc. I don't see any advantages of going to these asteroids compared to Moon and Mars exploration. I don't.
Well, if you look at this chart here, you're talking about delta V's and mission durations that are just different. And that leads to the concept of, okay, if you want to go and plan this human space flight, whether it's exploration or pioneering, human space flight roadmap to Mars that NASA's advertising right now, you will have a much easier time of it by selecting asteroids as stepping stone intermediate destinations. so that you can get used to wading around in the cosmic ocean.
Yeah, but that only delays our exploration efforts. And, you know, little bit of using moon for many, many things that we can use moon for that we cannot use Earth for. And then going to Mars, these kind of side expenses, side missions will ultimately delay our exploration of Mars. That's my viewpoint. Don't worry about it, but that
Well,
I just wanted to
let me
tell you.
toss another dimension out there. If you're schedule driven to the point of recklessness, I fear, because I've been involved in 2 space shuttle disasters. And particularly if you're not a federal agency like NASA with that kind of clout to, you know, assuage families and deep pockets from taxpayers to pay off the companies that were acting perhaps irresponsibly, you might find yourself farther behind for being reckless and going off half-cocked, like I said earlier. You might find yourself farther behind than if you've been responsible and done an incremental step-by-step, farther and farther, longer and longer mission duration, more and more Delta V requirements, possibly coming up with infrastructure on these asteroids that allows you abort options and greater cargo flow through your architecture.
Dan, let me give you my point of view in brief. I think moon will be a better testing ground for our mission to Mars than going to asteroids. Asteroids are going to be extremely difficult missions because of the radiation, the gravity situation, and the temperature situation, and even the vacuum situation. In other words, I think it's going to be a harder mission to go to an asteroid. It's not a piece of cake, and try to settle down on the asteroid compared to settling down on Moon and Mars. I'm sorry, that's my viewpoint. I think somebody is selling us something that is ignoring the complexity of settling down on an asteroid just because it's easier to reach there and easier to come back. No. It's much harder for the human to survive on an asteroid compared to Mars.
Well,
And
are you
compared to
talking
Moon, because we
pioneering
have a
or
data point on
exploring? And I'm going to move on because we have a real difference of opinion here that we aren't going to settle. But I will be touching on the difficulties once again and see if you don't get a little more information in a subsequent chart. So here's the proliferation aspect of small bodies. What we have here is the main belt of asteroids in green, which are numerous. And then here are the orbits of Mars, Earth in sort of a cyan color, Venus and Mercury. Here's the sun. And then these other colors that you see that aren't green, those are the near-Earth objects. The amazing thing about these, which we can juxtapose with all that sci-fi about Mars, is that in 1950, at the dawn of the space age, we only knew about 13 of these near-Earth asteroids. In 2000, after we had inaugurated some near-Earth asteroid search programs because we were starting to recognize that they pose a threat to the Earth, a threat of impact and damage to lives and property. We knew 879. And then as of January 28, 2022, I probably should update this, we knew about a little over 28,000. I think we're probably over 30,000 now. Yeah, probably pushing 50,000. And you can get the latest tallies by just going to this URL. So, you know, juxtapose that with being bombarded about Mars all the time, and no wonder we think it's easy. John Carter did it. And here's a sort of a bestiary of small bodies. They're all to scale. This was done for the Planetary Society by Emily Lakdawala. And you can see Halley's Comet here. This is the main belt asteroid, the biggest one in the group. Here are some other main belt asteroids. This is a near-Earth asteroid. It's actually the largest one that fits the definition of near-Earth asteroid. And then here's this main belt asteroid Gaspra, which appears on the next chart to show its size with respect to the outer moon of Mars, Deimos, and the inner moon of Mars, Phobos. And so you see these are on the order of 10 kilometers, these moons of Mars in diameter, irregular objects. And so my hypothesis that more successful pioneering can be done at less risk and expense on small bodies than on the surface of Mars. With the radiation exposure obstacle, everybody needs a subsurface habitat, no matter where they are, except in the sulfuric clouds of Venus, as we showed with Havoc. With reduced gravity, we need some kind of rotating habitats. So far, these hazards have to be dealt with the same way, no matter if your destination is the surface of Mars or a small body. This is where they start differing. Your access logistics. For the surface of Mars, you need an interplanetary transport plus some type of Mars-specific lander. Whereas for small bodies, you need the interplanetary transport. It doesn't really land on the small body because any of these objects we're talking about, like the moons of Mars, are so small that it's more like docking to the International Space Station. And so I would submit that some type of docking interface describing that is more accurate than saying landing on a small body. Marketable exports. If you're trying to pioneer, you need something to make your money off of. And who knows what that is. So once again, we have a draw here. And then for the logistics to export whatever your marketable items are, once again, we have this difference between the surface of Mars at the bottom of a gravity well with some type of, in this case, launcher that sends goods off to the interplanetary transport. And in the case of small bodies, all you have is your interplanetary transport. You undock from the small body and head for wherever you're going with no need to climb out of a gravity well. And when you talk about Mars-specific landers and launchers, they'll be expensive to develop, produce, and operate. So that's probably going to add on the order of a decade or more to your timeline. And they will also undergo stressful flight regimes that are not conducive to prolonged reuse, nor is a lander that's suitable for landing on the moon going to scale and adapt to landing on Mars. It's just not going to happen. Maybe launchers would be similar in those two, but you still have to scale higher for Mars because the gravity is greater. And it's why NASA sent all kinds of orbiters and flyby missions for decades. Let's see, the first Mars flyby was 1964, I believe, Mariner 4. And the first Mars landing was 1976. That wasn't a rover either. It was just a stationary lander. So, these missions are much more complex when you're talking about landing. And then when you're talking about round trip, you want to be responsible and bring your crew home. That really gets expensive, as our Mars sample return mission has proven. It's over budget and being replanned right now. The Chinese think they can send a Mars sample return mission, actually 2 spacecraft separate from each other, and they're going to launch them. I believe the latest I heard was 2028. And I'll be real interested to see if that comes off on time. So that's the way I see it. And the informed space pioneering plan for the 21st century that I would advocate for now, pending more data, is that we continue to explore the surface of Mars robotically from Earth. If extant life is there, it will be easier to detect and less likely to perish if humans aren't flushing the John there. And then to continue to search for and explore small bodies. I have a astrodynamics technical interchange group that I send emails to irregularly, probably averaging once a month over time. And 114 in that series is actually a white paper sent to the national academies for as input to their latest decadal survey. And you can find all the ATIG archives, including number 114, at this URL. And I should give a shout out to Douglas Yazell of the Houston section of AIAA for maintaining that wonderful archive, which is pretty much all my public domain research since retiring from regular employment and going into consulting in 2008. So this talks about exploring small bodies. And then study human adaptation to reduce gravity in low Earth orbit with rotating habitats. I think that's the only responsible way to go about even exploring Mars, let alone settling it, as well as other off-Earth destinations. And then develop routine interplanetary transport for humans and cargo. I published a paper, I think circa 2017 or so, about a Mars transport that targeted Phobos as its destination. It's available in sort of preprint form as another one of these ATIG. It's called Aquarius, and has some innovative concepts in it, like the crew habitat in the transport is situated inside a big water tank that then serves as propellant for the nuclear fusion engine. The whole concept requires refueling at Deimos. So you cache return propellant through robotic cargo logistics at Deimos, so that by the time you depart Earth, you have residual propellant to arrive at Deimos that is sufficient to provide some radiation shielding for the 8-month-odd transport, which is something no interplanetary transport that I'm aware of provides. In other words, dedicated radiation shielding mass. In this case, it's actually multi-use radiation shielding mass. And only after this paper was published did Lockheed Martin come out with the only exception to that statement, called, what is that? Mars Base Camp. If you've read about Mars Base Camp, that is not a nuclear propelled vehicle, it's chemically propelled. And the Lockheed Martin puts I believe just a Orion crew vehicle embedded in a liquid hydrogen tank for the cryogenic propellant. But that's the only exception. Everywhere else, there's no dedicated radiation shielding mask, even temporary, provided to the crew. So this is this next milestone, establishing rotating subsurface habitats on strategic small bodies. That is definitely going to take some technology, but I don't think it's near as much technology as figuring out how to put 20-ton packages on the surface of Mars in order to support humans there, including their landing craft, their partially fueled ascent vehicle, and habitats. Hopefully those are subsurface habitats, but I haven't seen much planning along those lines. A lot of hand waving. And then explore Mars with telepresent humans in a subsurface Deimos habitats. ATIG 115 is another companion white paper to ATIG 114, and you can read about it there. And then pioneer on Mars only if it's possible and ethical to thrive there economically and biologically. And we need to find out a lot. Maybe the biggest obstacles are the economic ones, because there is no unobtainium on Mars so far. So you can sort of justify exploring Mars with humans, assuming you aren't trashing the environment, which is the focus of scientific exploration that is really unique and could be really ground changing in astrobiology. This is Deimos from a distance of a little under 16 kilometers in orbit around Mars at a little about 20,000 kilometers. You're well within the data latency envelope of being able to tie shoelaces on Mars through a robotic surrogate there on the surface. You're sitting in a subsurface habitat on Deimos, controlling those assets, and you get to keep line of sight communication with them for over 2 Martian days, which is well over 2 Earth days, before it slowly rotates out of view. It comes into view here on the western limb of Mars, and then takes 2 days to transit across the disk of Mars, as seen from Deimos, before it disappears around the far side of Mars. And by that time, you could have another set of surrogates coming around in a different location. And you can see you can cover a huge variety of latitudes, almost to the polar caps, maybe to the polar caps. Really a great low latency telepresence base of operations here on Deimos, which is almost in an areosynchronous, the equivalent of geosynchronous orbit around Mars. That's sort of my end slide there, showing you in a nutshell what I think is for the foreseeable future, until we come up with conclusions like there's a compelling reason for humans to be on Mars, that they won't damage any extant life there. Until then, this is how I would want to explore Mars. And again, I ask planetary scientists repeatedly, what do you want to do on the surface of Mars, exploring it, that you can't do with a setup like I'm proposing? And you get to do it a lot cheaper, a lot sooner, and with a lot less risk. So, any questions?
See, Dan,
Yes,
I have 2 comments. One is that you missed a real important point here in going to Mars, and that is on Mars, once you're there, you can study the physics of that planet, and they get to know the how to terraform Mars. And terraforming is really the answer to a lot of the issues that you brought up. It takes a long time, but it can be done. And if you take a look at this book, I'll show it on my. It's called The Case for Mars by Robert Zubrin.
Yeah.
And if you read that book, he addresses a lot of the issues that you are bringing up, and chapter 9 has all to do with terraforming on Mars. Takes a long time, but it can be done, and it answers all the questions. The second point is
Well,
that
let me just address that one, okay? Why can't you do that even from Earth, let alone from the low latency telepresence base on Deimos? Why do you need humans on Mars to, detonate explosive devices and experiment with the atmosphere that they may be subject to undesirable effects from?
well,
Why do you
that's a
have
very
to be
good
on the
point.
surface?
Yes, that's an excellent point. And you certainly wouldn't do something on Mars that would destroy life, human life. But you do need, I think, humans there to explore what Mars is all about and the in-depth physics of Mars before you do a lot of terraforming. But you can start to do some terraforming that wouldn't destroy life beforehand.
Well, there is kind of a subjective term. I think on Deimos is there enough, because you have very, very productive exploration from a low latency telepresence standpoint. After a while, you have to ask, why do I have people on Mars that have to spend, the better part of a day getting ready for an EVA? The radiation clock is running at maximum speed while they're running around out there in a spacesuit. Why do you need that when you can do it all 24/7 from Deimos without spacesuits or any of that overhead?
Yeah, well, I think the first question is they want to establish a science base on Mars to do human exploration of possible life buried underground a certain number of meters. And that's taking care of the John Flushing that you mentioned. That
is a
second-
loser. It is a loser for the reasons I've stated. And I don't see why I'm not making any headway with you on it. You'll do the job better and more productively, cheaper, with less risk, for less money, if you do the job close by, not on the surface with the humans.
Well, that's a good point, and it has to be explored. But I would still say that humans on Mars need to be done to start the whole process. But my second point, and supports the first point, is that by going to Mars and living on Mars, we will learn a lot more about planet. It'll force us to learn a lot more about planetary physics, which we need to know. And what do we need to know it for? To help Earth. The things that we'll learn about planetary physics from going to Mars and living on Mars will help us understand more about how to take care of our own planet, Earth. And we do need those solutions. And the innovation line is the most important thing there, and worth a lot of problems that would take for living on Mars to start with anyway. So those are my two major points.
Okay, the second point I have the same response for. Why can't you do it from Deimos and thereby get started with the job sooner, do it at less expense, and do it at far less risk?
Well, that's a good point, and you can start it there, but I maintain that you need to go farther than that, and that's what you need to do. Both Deimos to start with, if you want, and then on the surface of Mars for sure.
I highly recommend you take a look at a city on Mars.
Okay, and I recommend that you might want to join the society called the Mars Society, and also attend the conference that's held in Washington every year. That's called the H2M conference, and it's Humans to Mars, and they answer a lot of those questions that you have.
Well, I don't have money to travel to events like that, but thanks for the suggestion. Go ahead.
Thank you.
Kumar?
Yes, sir. I have a difficulty, really, you can straighten me out. I have a difficulty of understanding how did landing on an asteroid become so easy and doable when there is no infrastructure on these asteroids. I took a course from Caltech on asteroid belt. There's I was taught that the orbits of these asteroids are unstable. etc., etc. But when I compare the temperature, the atmosphere, vacuum, whatever, radiation, gravity, if I compare that for human exploration on asteroids compared to moon being a training ground, learning ground, etc., for human exploration of Mars, I see some problems. It's not so easy to have a human mission to asteroids. It's going to be a lot harder than people are selling it, just because accessibility, it's easy to go there and easy to move around, doesn't solve the problem of what does an asteroid offer in terms of temperature, atmosphere, radiation, gravity, etc. to even sustain human being. We have learned something on the moon. We had 12 human beings on the moon. We have a body of knowledge. Moon has incredible things to offer for betterment of human life. In other words, the things, the experiments that we cannot do on the Earth, that require vacuum, that require 18% gravity, etc. We can do them on the moon. We can build labs that are costing us arm and leg on the Earth. Now, I must be missing something, and you can correct me. I see asteroid exploration as a must for robotic missions. And I think there's lots of things there that maybe we can even harvest. And this is a perfect, mine for us to do the mining, the robotic, asteroid belt, but not for human exploration. I rest my case. I'm going to shut up. But my thinking is use moon, learn a lot, build some labs there that require vacuum. That's what I said in 1979. I was asked, I gave a one-page written answer. Why do we have to continue with the moon? And I made my point. There are things that we cannot literally do on the Earth that we can do on the moon, especially in the domain of science and technology. I rest my case. I'm sorry, I brought up this whole
Remember that the context of my whole presentation is the ultimate destination is Mars, whether for exploration or pioneering, the ultimate destination is Mars. And so the moon furthers that goal to a certain extent, only because we are so ignorant, particularly with human spaceflight, of what it's like to operate in deep space outside the Earth's magnetic field. But if you're talking about the environment on the moon being more hospitable than it is on these small bodies like near-Earth asteroids, I don't see it. They're both, there's no atmosphere to speak of. There's no gravity to speak of on a small body, but I see that as an advantage. Now, yes, there are things to be learned about emplacing subsurface habitats on a small body, but there are things to be learned about emplacing subsurface habitats on the moon as well. So, we're starting from a state of extreme ignorance, but I think in terms of the logistics of getting humans to Mars, you're neglecting an awful lot about small bodies that are in near-Earth asteroid type orbits. For one thing, those orbits over eons may not be stable, but over the period of human history, they're quite stable. And if humans are actually using those near-Earth asteroids as waypoints or as resource sites to obtain resources from, they can be controlled to whatever extent is necessary, I feel.
We can do that robotically. We can use
Absolutely. Absolutely. And then
assets
you
on
can
them.
emplace,
We don't
you
need
can
a
emplace a
human
way
mission.
station on Deimos
See,
robotically, and
Dan,
then
my
it's
point
ready
is-
for humans to use when they arrive.
My point is this: we can use these asteroids with robots. We can learn a lot. We can put things that we want to put on Mars on these, but we have robotics. We have intelligent systems that can use some of the advantages of these asteroids. But I don't see any advantage of substituting moon with an asteroid for human learning, human exploration. I don't see it. Maybe I'm wrong, but I will
Well,
discuss with you offline. Sorry,
Let me return to my proposal about what can be done from Deimos in exploring Mars. You can't settle Mars from Deimos, that's true. But you can, there's nothing I've heard of that you want to do on Mars that can't be done with low latency telepresence with humans on Deimos. And if that's true, then exploring near-Earth asteroids gets you a leg up on doing low latency telepresence from Deimos. The emplacement of habitats will be virtually the same. And then the low latency operations with Mars can be explored to your heart's content on these near-Earth asteroids. So if your aim is to explore Mars and maybe someday settle it, I think small bodies get you a leg up to that end better than the moon does. You have more feed forward, to use a NASA buzzword.
I think we different point of view, but there are others who have questions. I better shut up.
Yeah, Dr. Kumar Krishnan, I remember, we had long discussions in professional groups, IEEE and on and on and on, when we were talking about the human in space, whether we should simply have stations or settlements, not for humans. We had long discussions on those things. And again, there were advantages and things. I think something that we need to start looking into is the hurdles for the long duration travel and, taking about 56 million, all that distance. Maybe we can look into the intermediate settlements, floating type, that can reduce the long travels and things of that kind. I saw there was sometimes back, there was a paper written by the Apollo 11 pilot, not pilot, I mean the
Buzz Aldrin?
Yeah, he wrote about the Venus and something about some ideas of the settlement that could be done. So again, when we do the pioneering, before we do the exploration, we look at the hurdles and try to settle hurdles and be comfortable with those overcoming the hurdles, and then move on to the next step. I think some efforts are being done in those directions, but I think some of the things could be done with the robotics arrangement, but eventually, if there is a sustainability of life on some of those destinations, I think those things have to be looked at. I'm just throwing some of the thinking process on that one, thinking loud. And
Yeah,
thanks,
I think,
Dan, for a good, very nice presentation with all the details. Appreciate it.
You're welcome, and we'll get charts to everyone soon.
Excellent presentation, Dan. This is Kumar. Excellent presentation.
And Kumar, I think we are in agreement that if your aim is just to mine resources from small bodies, you will always wind up with a bigger profit margin if you can do it robotically without humans at all. It's just too much overhead. But when it comes to pioneering, the way I've defined it, that definition requires human presence.
Could I just make one more comment, and that is, I have an issue with your second slide that says that we don't need to go to Mars because there's no problem with the maintaining the survivability on Earth for 100 years. As a matter of fact, there's about 6 or 7 different scenarios that could easily happen in the next 100 years that will put survivability on Earth at a very challenging point. And I think that's really the area that Elon Musk and many other people believe that going to Mars is necessary for a second planet, a plan B, if you will, for survival of the human race. And so that's the major reason for going to Mars and settling Mars.
Well, I don't disagree with you entirely, but I hope this presentation has opened your eyes at least to the possibility that Mars may not be the best place for Plan B.
I think that might be true. I thank you very much, and that's a good point.
Okay. Yep. Thank you very much for everyone for all your questions and challenging my thinking. That's the way things get worked out. Thank you. Any other questions? I'm going to stop sharing. I'm going to stop sharing.
Yeah, that's fine. Dan, for people to go out, of course, they need water, and water is heavy. On Phobos and Deimos, do they know if there's water available? I mean, the moon, they keep on finding, first they said just the poles, and then they're saying it could be under some of the other soil beyond the poles. Any under the soil or under the surface frozen in there in Phobos and Deimos?
The really sad thing about Mars exploration, and from my point of view, is that there have been no missions dedicated to studying Phobos and Deimos. I have in one of those citations, one of those ATIG white papers, I've written why I think, based only on the bare minimum of information about the physical characteristics of the 2 moons of Mars, but we do know at least their orbits and their sizes, why I think Deimos is a better venue for human exploration. And there's like a half dozen reasons. Exploration not only of small bodies, but of Mars itself. It's just a better venue. And if you go to that white paper, you'll see them listed. I'll be happy to send any of these documents to anyone, but you can also just click on the URLs and get them yourself.
Okay, so great. And just thinking about the atmosphere of Venus, is there any water in that sulfuric atmosphere that you could pull inside of your floating craft?
Very little water, but at other depths there may be. I'm trying to remember. One of those URLs gives a profile of various characteristics of the Venus atmosphere, and I wasn't really looking for water at the time, but you may be able to find it.
So maybe you could send something robotic from your floating platform to that layer, collect the tank of water, and come back with it.
It may be as simple as a bucket on a winch. I don't know.
that
but it's going to be pretty hot down there.
Well, yeah, you got to build everything to stand the heat, but yeah, collecting some water vapor and bringing it back would be
great.
Yeah. All right. Thanks so much for your talk. This has been super interesting.
Oh, my pleasure. And I'm actually giving it 2 more times later this month. So there's a lot of interest.
So you had a good dry run or preparation for the next talks as well. And yeah, I wanted to join everyone in saying thank you and thanking you for presenting. And as we promised, it is a thought-provoking. It is to some degree could be considered a controversial because it differs from other opinions, but it is an offer, it is an option, and I agree with Dan that everything needs to be explored, and there's a place, time and place, and definitely both in history and in exploration in science. We explore not only with humans, we explore with robotic missions and various types of analysis simulations, and that it shouldn't be ignored. I wanted to bring up to everyone's attention before we start losing too many people that there's a few upcoming events. Zafar had extended graciously invitation to next Friday webinar about from teleoperations to telepresence. There's also, unfortunately coinciding with the same time, roughly, is AAA Houston section, James Webb Space Telescope and Technological Wonders. That is a continuation of this series of, I think there's 3 in that series. Dr. Hashima Hassan, she was here, presented about a month or 2 ago, and this is going a little bit more in depth. And then there will be also, yes, next Saturday, we have another speaker here, almost forgot, Stephen Ryder, and some of you may have known him. He has been at Johnson, and I think now he's working at headquarters as in the technology development, emerging technologies. And so the topic of presentation will be harnessing the power of crowd, NASA's open toolkit for keeping up the acceleration technological challenges. So I am looking forward to his presentation. We'll see how the power of crowdsourcing improves or contributes into the types of, there's always types of exploration and new discoveries. There's definitely a power in the crowd and sourcing that power and harnessing that power. We may solve some of the technological problems with addressing at least the challenges with the telepresence. And I reviewed some of the open challenges that the office offers to universities. And Catalina, maybe you can also extend to your colleagues an invitation, or later on they can review, obviously, a recording. And again, I wanted to thank everyone for attending and supporting AAA. AAA is a volunteered organization, and all of us, we're not getting paid to be here. It is our passion for space exploration, whether remote or in-person exploration. And so I thank everyone for being here and being curious. So keep on being curious, keep on exploring. And Dan, most of all, thank you for sharing your passion, your knowledge, and provoking thoughts for future explorers. So thanks for everyone for being here.
Thank
Yeah,
you.
so
Great
Elena-
presentation.
So Elena, this is Radha. I think I'm personally grateful for all these things that you do. It's a great collection of the knowledge that is being distributed to all of us. So it is really great. I just want to let you know that next Friday, the thing which I sent is at 9 o'clock in the morning.
Oh.
And I think AIAA is much later. So again, it's we arrange, some of us arrange with the distinguished speakers from other countries, and probably he's from South Africa, but he will be presenting from Beijing. So anyway, just to let you know. Thanks a lot, Svetlana, and I think I always envy, how you arrange these beautiful presentations to enhance our knowledge. Thanks.
Dr. Takvi, I agree with you 100%.
Okay, thank
She
you
is
so
great.
much.
She is great.